boys and girls, let us see one example on how to apply the concept of heat conductions. So this question, we need to calculate the rate of heat flow through a glass windows of 3 meter squared in area and 3.2 millimeter thick if the temperature at the inner surface and the outer surface are 15 degrees Celsius and 38 degrees Celsius. So I visualize the problem. This is the glass windows. The area is 3 meters squared. The thickness is 3.2 millimeter. So the outer surface is at 38 degrees Celsius. Inner is 15 degrees Celsius. So here, outer surface have a high temperature and inner surface have a low temperature. So there is a temperature difference between the outer surface and inner surface. So what happened? The heat will transfer from the hot region, high temperature, towards the low temperature. Okay, across the thickness of the windows. Across the thickness of the windows, there will be heat transferred from outer into the inner side. So we need to calculate the rate of heat flow. How fast the heat is being transferred from the outer surface to the inner surface. So we take out the equations. Rate of heat flow is given by negative Ka dt over x. So K is the thermal conductivity, A is referred to the area, dt is referred to the temperature difference, the change in temperature. So the change in temperature will be the temperature final minus the temperature initial. Okay, x is the distance travel by the heat, or the length. So we put in the value. K is 0.84. The area is 3. Then we find the dt is the change in temperature. So heat flow from high temperature to low temperature. So this is the initial temperature, this is our final temperature. So we must take 15 minus 38. Okay, divide by the distance travel. The distance travel by the heat across the glass windows is 3.2, but the millimeter must change it to meter. So times 10, milli is negative 3 meter. Okay, change it to meter, SI unit. Okay, then we can do our calculation. We can press calculator, do our calculation. We will get the rate of heat flow will be 1.81 to the power of 4 watt.